This is Arne and welcome to this video. In this video I will go into detail of a smaller scale version of the Klassen 180 at 1.8 meter length, ready for 3D printing on a regular 350mm diagonal 3D printer. I will go into detail how to calculate the displacement of this hull and what to look for a perfect 3D print. I had rigidity in mind, so the bow section is a little thinner so we can backfill with a composite. We can use epoxy putty or something with fibers included. I want everything to be super easy to print and super easy to assemble, so the second section fits perfectly into the bow section. We can then bond a plate onto this surface, which will give us the security of a crash bulkhead. Further down the hull you can see I have addressed the common issue of overhangs by adding a little chamfer onto our bonding area. The next section of the hull bonds to the main structure with a main bulkhead where the mast sits, and we have a little different connection. Also added are these round and square tubes to have something to insert carbon fiber rods and tubes. This will later give us enormous amounts of rigidity for this hull. These protruding areas also act as mounting points for the hardware for the stays. This main bulkhead and also the stay area indicates that we are in the middle of the boat. A little frustrated from other designs, I thought let's give this boat a flat surface where we can mount every keel option out there. This flat surface ready for mounting every keel option out there should give us the opportunity to develop canting keel systems and put higher and higher loads onto those hulls. Speaking of load distribution, just in front of the main sheet post we have these three posts that support the deck structure from shifting from left to right, and on top of the deck we have also a recess where we can place a carbon fiber plate to further down even more reinforce the deck structure in this area. Coming from the main sheet we will go to the steering system. You can see in the rear of the boat we have two holes ready for the rudder stocks. Twin rudders? Yes, because it looks good. And we can add T-foils to the rudders, because this boat is supposed to foil. Some experience and also the help of computer-aided design gives me the chance to already include the penetrations into the 3D model that we will need for the steering system. Peeling back the tape, we can open the hatch and have access to all our servos. I was always freaking out about narrow hull openings, so I'm pleased that we have plenty of space to fiddle around and work with a cool mounting plate. Another reason why I wanted to have such a big opening is to have the access to the main structure. This gives us the opportunity to build a canting foil system on the left and right to the boat. It has always been my dream to have a hull that we can work with, that we can experiment with, and there are endless capabilities. Including the base plate for the steering servo is always a great thing. This saves time and completes a well thought through boat. Above the waterline is the rigging gear. It has always been a challenge to build the best mast. It's always been the challenge to make it stiff and strong and yet as light as possible. This mast box can be still modified, is currently 10mm wide and gives us the chance to build whatever we want. I will cover the whole mast building process in detail in one of the next videos. As well as manufacturing techniques, also the shape of a hull has been changed over the years. This quite modern shape still displays some water when sailing slow. How much water is easy to calculate with Fusion 360. To give you a better understanding of the whole hull shape, we go back to Sub-Zero. I want to tell you why this hull looks like it looks. I wanted to have the bow section high up and also the transom as high up as possible. This makes the boat really lively. No gain without drawbacks. So we have to do a separate video on hull design in the future. If you don't want to miss this, please subscribe to this video and make yourself a favor. Let's make a construction plane through 3 points. And here comes the trick. This gives us the waterline when the boat is heeling. We can now cut our body and calculate its volume and therefore its displacement. This is what the waterline looks from the top. We definitely have to talk about it, but in a future video. We can now see by right-clicking onto our part the properties and therefore its volume. Let's change the density from steel to water. Change the material to water and also press A and go to liquids and change the appearance to water. By now you can probably see where this is going. Let's have a look on the properties of our selection. We have a density of 0.01 grams per cubic millimeters and therefore a total mass of 24,000 grams. Remember, this is our Sub-Zero project, so it's 2.5 meters long. If we would build this boat with this geometry and it would weigh 24.39 kilograms, this would be the exact water displacement and the exact waterline that we would achieve. With everything in life, there's a big drawback. We haven't considered this boat is flowing through the water, so it will create some waves. And here comes hull speed and wavelength into play. Let's continue with our printable boat. With this method of changing properties, you can also evaluate the volume and the material you will need to print this whole boat. For example, for this rear section, we go to Material, say it's water, press A to show it as water, and go to Properties to check its volume. Right now we have 1200 grams, that equals 1200 cubic millimeters of filament needed if we would build it in full. But as you have probably guessed, we will build it with a outer inner wall and some infill, so we will end up with a different amount of filament needed. In this case we have 573 grams of filament. Because printer settings can be pretty tricky, I usually calculate the whole volume of all my printed parts and see how much effect it does to change maybe from one outer wall to two outer walls and to change the infill. And sure enough, a video about printing and building this boat will come for sure. Our volume of the printed parts is right now 5.7 liters. We have to reduce this as much as possible to save as much as possible. I estimate a total weight of 0.25 to its water volume. That equals for this 1.8 meter hull at around about 1.5 kilograms in total. Not too bad, and this gives us plenty of opportunity to make it stronger, lighter and faster. All parts need to be bonded and we have some carbon fiber reinforcement, so the next episodes will be pretty exciting. Until then, subscribe to this channel, leave a comment and see you next time.